Hello students, today's topic is that relative velocity. What? Relative velocity. Relative means this is a one kind of relation, and this is what? Velocity. Means in this topic I will discuss here different relation of velocities. Means we can say we have two body, one is A, second is B. So simply we have to compare the velocity of both bodies. Means A is moving in this direction, B is moving in this direction. Then what is the velocity of A with respect to B, and what is the velocity of B with respect to A? So in this topic I will discuss with you all this is the relation between different velocities. When we look out from the fast moving train, taking one example for it, the object like trees, houses, etc. appear to move with certain velocity in a direction opposite to the direction of the moving train. Moreover, another train moving on the parallel track is in the same but slowly. Two our train also appear to move in the opposite direction. Clear? Then, however, a train moving on a parallel track but faster than our train appears move forward with a velocity less than its actual velocity. Clear? Means all these facts can be explained on the basis of the concept of relative velocity. So a small derivation related to the this means a topic like that relative velocity. I'm going to explain this one, that is the relative velocity. Means we can say, first of all, I'm writing here definition of it. Relative velocity means what is relative velocity. Clear? Then listen here. Relative velocity relative velocity means relative velocity of an object that is A, of an object that is A with respect to another object B is the time rate. B is the time rate at which the object A changes its position with respect to the object B. Clear? Means first simple meaning of it that we have to compare velocities of two objects, that is one is A, second is B. Means firstly we will focus on one thing only. B, A is moving with respect to B, how much velocity it gains, more, less, anything else. These different relative concept I will discuss here. Okay, first of all, to understand the concept of relative velocity, we have to consider two objects. One is what? A, and second is what? B. Both bodies A and B moving uniformly with velocities, different velocities. We can say object A has their velocity that is v1 and B has their velocity that is what? v2. Clear? So we can say initially we have a position. Simply I'm drawing the diagram for it there. Simply we have this is our straight line, clear, on which both body A and B will move in forward direction. Okay or not? Okay, so I'm saying here this is our first point. O means origin means this is our initial point. Clear? So we can say this is our A object and this is our B object. Clear? We can say means object A simply at time interval are present at this displacement. Okay, this position. So we can say this position is what? x01, and B means object B is present means at this position, that is x02. Clear? Okay or not? Okay. And in the case of after, we can say here when object are present at point A, so on that time the time period for it, that is how much? T equal to 0, and this also how much? T is equal to 0, and we can say this is the gap between both bodies. Clear? When we have a time period T equal to 0. Clear? Now let x1 and x2 be the displacement of A and B respectively after time t. Clear? So simply we can say here after time t the displacement for both bodies like that A and B, that is we get these are the body A and B. Clear? So we can say both bodies are present at time, which time? Time t. Okay or not? Okay, this body also at a time t, so both bodies are changing its position. Clear? So we can say up to this point to this point total distance how much, that is what, x1, and up to this point to this point total distance how much, that is what, x2. Okay or not? Okay, so initially when time interval time taking there t equal to 0, on that time displacement, that is the 0 to A, means we can say O to A, and second is what, O to B. And same thing when after some time, means we can say time can be anything 1 2 3 4 15 100 second, anything else. So on that time we have a position that is O to A, and second is what, O to B. So we noted here that different position here means related to it. Clear? Means how much distance covered by the body A from t equal to 0 to t is equal to t. Clear? How much distance covered, displacement covered by body B, means from time interval 0 to, within time interval 0 to time interval t. Okay, so these things I will observe here. Listen carefully. So that the displacement of the object A in time t is given by, means we have object A, this means our object reached up to this point to this point. Okay, so displacement covered in time interval t. So first of all I have to find out time means how much time is there. We can say from this point to this point, we can say this point is t and this is point is 0. So we can say I got their time, that is what, t, minute, second, or anything else. Okay, then here I will find out the displacement. Then find out displacement. How will I find it? Means up to here this displacement how much, x1, and initial of body, that is x01. So we can say x1 minus x01 is equal to velocity v1 into t. From where we are getting this one, we know that velocity is equal to what, displacement upon time, and displacement upon time, and displacement is equal to what, velocity into time. So we can say displacement covered from this position t is equal to 0 to this position t is equal to t. So we can say we can subtract from this total means displacement minus this displacement, means in one dimension. So x1 minus x01, then I got here how much, x1 minus x01 is equal to v1 t. So we can say x1, this 01 moves another side, get here that plus v1 t. We can say this is our equation number 1. So this is for body A. Clear? So we can say for body B, same thing, same concept we will apply here. So we can say here x2 minus x02 equal to what, v2t, right? So x2 is equal to what, x02 plus v2t. We can say this is our equation number 2. This is our equation number 2 for finding total displacement, means how much gap are present between both bodies, how much gap are present between both bodies at initial point and its final point. What will we do? We will subtract from this x2 minus x1, then we will get this gap here, and this x02 minus x01, we will get this gap from this side. Okay students, then what will we do? Simply we will subtract equation 2 to equation 1, then we will get which things. I'm just going to write here. Listen, I'm writing here again equation. First equation at for object A, that is what, x1 x01 plus what, v1t. This is our equation number 1. For second, x2 is equal to x0t, that is what, v2t. Or for finding the distance between A and B, so we will subtract from 2, equation number 2 minus equation number 1. We can write x2 minus x1, that is what, x02 minus x01 plus v2t minus v1t. Okay students, then after that what will we do? X2 minus x1, that is x01 2 minus x01, then take t common. When we will take t common, then we will get this equation. Clear? So simply this difference between this point, the distance between the gap between, we can say the, after subtracting we will get here one value, that is x2 minus x1 is equal to x, and we can say same for thing x, same for it, x01 that is what, x naught. So we can write that is what, x is equal to x naught plus v2 minus v1 v2 minus v1 into t. So we can say x is equal to x naught plus v2 minus v1 into t. So this is our main equation which showing here relative concept between velocity. This v2 minus v1 will show here the relation between the velocities of the first body and the second body. Okay, so by the help of we can find out the things. So here some special cases which I am going to discuss. Clear students? Special cases, listen carefully. First case, one thing you have to remember, if we have object A, object B, so we know that its velocity is v1, its velocity is what, v2. If we are going to find out relative velocity A with respect to B, A with respect to B, so those things which will be in respect means A with respect to B, so we will write A first, then B later, then we can write v1 minus v2. After that what, B with respect to A, then we will write v2 minus v1. Okay, both cases are simple here. So some graphical representation I will discuss here with you all. Number one, special case number one, that is number one. Clear? If velocity of first body equal to velocity of second body, so on that time we have a equation that is what, x is equal to what, x naught plus v2 minus v1 into what, into a t. So we know that v1 is equal to what, v2. So on that time what will we do, x is equal to what, x naught, so v2 minus v2. Okay or not? Okay, so into t, so this term becomes 0 because when we will subtract here, so we can say there x0 equal to x naught, means the distance between the final velocities, final position of the object equal to the initial position of the object. So we can say there at both places the gap between the both bodies will remain same, nothing will overcome, nothing will move forward, nothing will remain backside, all things will move parallelly. So simply by graph we can show this is in this side I am taking here what, time period, in this side I am taking what, displacement. Clear? So we can say these 2 points are the initial point, means we can say this point O, this point is A, this point is B. So here displacement x01, x02, then body will move with a certain velocity in the forward direction. So both things, because we know that both things will remain parallel and will cover equal distances in equal interval of time. If this body is covering 5 meter, so this also will cover there 5 meter, 10 meter, 10 meter, so at both points, so it will remain same. This is for object, this is for object B, or we can say this is for object A. Okay students, so this is the simple graph between when velocity v2 v1, so in this graph velocity v1 is equal to v2. Clear? Second case I am discussing, second special case. In this case what will we do, one time we will take v2 greater than v1, second time I will take v1 greater than v2, v1 greater than v2. Clear? So simply I am taking equation what, x equal to what, x equal to what, x naught plus v2 minus v1 divided by t. If we can say here v2 greater than v1, v2 greater than v1, on that time what will happen, x equal to x naught plus v2 greater than v1, so v2 is bigger and this v1 is smaller. On that time we will get what here, positive, means we will get here positive result, okay, into t. Clear? So we will write this equation in this side, so x minus x naught is equal to positive t. So we can say if difference between x minus x naught equal to positive, x minus x naught equal to positive, on that time we will draw a graph between the bodies like it. See here, simply this is side time period, this side we can say that is the x-axis, so we can say this point is what, x01, this point is what, x02. So simply listen here, this is our A body, A object, this is our B object. So simply I am taking here what, v2 greater than v1, so it means that its velocity is more than that of object A. We can say this object is A, this object is B. So when its velocity is more, so it will move faster and this body will move slower. So we can say the gap between the object will increase. Okay, so we can say this object has their faster velocity, means v2, it has a less faster, so we can say v2 greater than v1 for this graph. Okay students, third case simply we can say if v1 greater than v2, if v1 greater than v2, then on that time we can write equation x is equal to what, x naught plus what, v2 minus v1 into t. Clear? So take this one in this side, x minus x naught equal to, if v1 greater than v2, so on that time we will get negative result. Negative result means when we will draw a graph between them, this is our time period, this is our displacement, this is our object A, that is x01, x02. So on that I am saying there v1 greater than v2. So velocity of A is more than that of B. So B will move slowly and this A will move faster. If this A will move faster, on that time it will cover more displacement within a less time period. So this point will increase in less manner and this will increase very fastly. On that time this A object will cross the B object. Clear? At this point. Clear? So by the help of these kind of graphs we can find out the when both bodies will cover cross together and up to which distance of covering, how much distance both bodies will cross together. So that point will be the C. At C points we can see there both body will cross to each other. So this point we can include here, means we can say here that velocity of first body is greater than that of velocity of second body. Okay students, fourth case. Fourth concept is very important concept in this case. Simply we have to include two things. Number one is body is moving in forward direction, and one is the opposite of this direction, means backward direction. So by the help of both velocities we will find out the resultant between them. How we will find out? Listen one thing, if a body is moving A in forward direction, second body moving in backward direction, B, on that time we can say its velocity will be what, VA in plus, and we can say its velocity will be VB in minus. So we can say this is V1 or this is what, V2. Clear? So we can say we are going to find out the, well, one body is moving forward, other is moving in the backward side. So on that time we will find out the velocity of A with respect to B. Velocity of A with respect to B. So we can write that velocity of A is what, V1, and velocity of B is what, V2. Okay students. So one thing, listen, if V1 is moving forward side, so we can say it is plus. Clear? And V2 is moving in back side, so we can say it will be minus V2. So it can say V1 plus V2. So positive sign we will get here, means both velocity will add. So we can say if one train is moving in this side, another will move in this side, so according to it its velocity will become means after adding of this velocity we can say, so this is 40 and this is what, 60. So observer when will see this object, so he will see there means this train will move with the speed of 100 meter per second. Why? 40 speed of it and 60 speed of it. That, so on that time we can add both velocities. So we can say body will move with a 100 meter per second speed. Okay or not? Okay. So simply we can include here, if means both body will move in different, means opposite direction, on that time velocities of the body will add. Okay students, so these are the simple things we can include here in this case. Next topic I can say here, if VB with respect to VA, VB with respect to VA, on that time what will we do? So we can say, simple I'm taking, so we can say VB minus what, VA, VB minus what, VA. So we can say here VB is what, VB is what, you can see here VB is in opposite direction. On that time we can say this is what, minus VB, and this is what, minus VA. So minus sign you can take common, then it becomes VB plus VA, means both things will add in the, means both things will be in the opposite direction, and we will get the negative sign in the both cases. Okay students, this is the simple understanding. Next, if both object means both object move along parallel and in a straight line, then what will we do? So we can say this is object A, this is our object B. So its velocity what, VA, its velocity what, B. So both are moving in the same direction. On that time velocity will subtract. How will we say? So we can say if A is moving with respect to B, A is moving with respect to B. So on that time we can say VA minus VB. VA minus VB. Yeah, you can say B with respect to A. So B minus VA. Clear? We can say first body moving with 15 meter per second, second body moving with how much, with second, how much, means we can say its velocity will be there, how much, 30 meter per second. So simply I'm asking, this is A, this is B, A with respect to B. So I can say that this is 15 or this is 30. So I will get here minus 15 meter per second. Okay, this train will move forward than that of this train. Okay or not? Okay, if I will ask from you that B with respect to A, then I can say 30 minus 15. On that time I will get here 15 meter per second. Okay students, and last and final point in this case, if both objects A and B move along straight lines but in the opposite direction, so I can say VAB means A with respect to B. So we can say VA means B in the opposite direction of A. So we can say that VA, the velocity will add in both cases. So simply, if B with respect to A, B already in the opposite direction, and A we can say same like it in the forward direction, so we can say it becomes minus VB plus VA. So this is the simple explanation related to your relative velocity. Next time I will discuss numerical problems of it. Okay students.